one more try. This is our calendar for today, and we are going to kind of just tie up the loose ends from last week and Earth Day, and then talk about the last little teeny piece of the section 2 notes on moles to mass and moles to volume. And then we'll get started on some calculating. So that's why you need your calculators, of course. There will be some of it you will need to do for homework. Why am I in physics? I don't want to be in physics. Technology. All right, your choices. What did you come up with? Luke, something that you noticed from the list of things that we should probably do here at Sonora High next year. Anything? Huh? Okay. That's a good idea, huh? I like that. Water bottle for everybody. Of course, we can't open up the refill stations right now, but hopefully soon. How about another one, Kennedy? Recycling was a recurring theme for sure. So trying to get some better or get some out. We used to have some bins, what they were like on these foldy. Do you guys remember what I'm talking about? The metal frames, and they had bags and stuff, and they blow over when it was windy. But maybe we can get some better type of recycling bins besides all the garbage cans. The issue, of course, with recycling bins, like these two things, they're not garbage cans. They're for recycling, but they look like garbage cans. So people throw their trash in there, which is more of an issue when you're out on the main campus. But anyhow, but that's a good idea. We definitely should do that. And how about one more? Leela, what's another idea that you saw that you liked? So I can find you. You can type it in the chat or you can unmute, whatever works for you. You were here, right? I saw you come in. Yeah. Any ideas, Leela? Type me something, girl, so I know you're there. Esme, give me something else.
But, like recycling, like the water bottle, just got something to recycle the hand sanitizers and the masks.
Oh. I wonder, are you guys aware of any place to recycle masks? Or the little plastic bottles, obviously. It said plastic was a huge thing, and a lot of people said something about that. Trash pickup and that sort of stuff. So hopefully if you're here next year, which most of you will be, we can work on a plan to try and put some of your good ideas into action. So be listening for that on the bulletins next year. And see if we can't get some more environmental activism on campus. All right. So the next item that should be in your classwork feed right now is practice calculations. And I'm going to make myself a copy for this period. And you should open that up and have your handy dandy calculator. Honestly, those of you present and even those of you at home, you really should try and just handwrite this stuff. It's so much faster than trying to type it in. And it makes better connection with your brain cells. So it really will make a difference. Huh?
So we can like fix that right on it.
Yeah, you can just use a piece of paper. Do you have paper? Okay.
Oh,
Yeah, like binder paper, and then take a picture of it and upload it in the document for your points. But I just really think it's a good idea.
If you want the questions to be written down,
You don't need to write the questions down. So, but do separate them by a space or something so it's easier to find. Okay. It is so much better to write things out, and it goes faster, and I just think synapse is better with your brains. Okay, so we have one little teeny bit to talk about before we jump into these problems, but now that you're all prepared, you might even want to write some of this down. So if you recall, we left off talking about molar volume, we talked about grams and Avogadro's hypothesis and all that stuff. I mean, it's been over a week, but doing calculations can be difficult. And the tricks I'm going to give you are to help you keep an order. It seems like such an extra burden to have to write down units, but it really will help you in the long run. So you guys know that these two conversion factors are equivalent. Okay, the top is the same as the bottom. They're just different units. If the 12's in the numerator or the 12's in the denominator, you're doing something different with the number that you're starting with. Okay, so if the 12's in the numerator, what mathematical function are you going to do with 12? Multiply or divide? So numerator stuff is multiply. If it's in the denominator, what are you going to do with that 12? Divide by it. So you can set both of these unitary rates, these fractions up to make it look like you're doing multiplication the whole way, but the numbers on the bottom get divided into the numbers on the top. So if I use this one, my answer is going to come out in inches. I'm going to take number of feet times 12 to get inches. If I use this one, my answer is going to come out in feet. I'm going to have inches divided by 12 gives me feet. Same kind of thing happens with this mole stuff. Okay, so moles are at the center. You have to go through moles. Moles just make it easier because they're more compact numbers. You don't have these huge, ginormous 10 to the power of 56 or whatever when you're counting particles. It just makes the numbers a little bit more manageable. Okay. On this one, we've got mass. And this diagram's on the note sheet and it's on the problem sheet for today as well. We got volume and we've got representative particles. Okay. Here's the trick. It's really, really kind of cool. So if you'll notice on here, it's going into moles. I can take a mass, and of course the unit for mass is, yes. I can take a number of grams and I can multiply by 1 mole per number of grams, the molar mass. That means I'm dividing by the molar mass. Okay, if I want to come out of moles into mass, like I did for this, or I want 1 mole of zinc, I'm going to look on the periodic table and see what the mass of 1 mole of zinc is and weigh it out. Okay, I can take the molar mass, and if I wanted 2 moles, I'd do 2 times it, right? So I have the molar mass. I'm going to multiply or I'm going to divide. Same kind of thing happens when you're doing volume. Remember, volume is in what unit? Liters, thank you. And this is for at STP, which you're going to have to look up. So if I want to go from moles into what size container I need to put it in, I'm going to multiply by 22.4 liters per 1 mole. Okay, if I want to go from a volume and see how many moles I have, I'm going to divide by it, which is the same as multiplying by the inverse. Same kind of thing with representative particles. If I want to go from moles to representative particles, I'm going to multiply by the number of things in a mole. Like if I said I have a dozen donuts, okay, you know that it's going to be 12. Okay. Well, It's not a dozen for moles. It's a big number. It's crazy. So again, I'm going to multiply by 6.02, the number of moles, by that to get these. Or if I'm going the other way, I'm going to divide by 6.02 times 10 to the 23rd. Okay, so the takeaway, the thing I want you to try and focus on, I don't know why he's doing that, is oops. Okay, coming out of, let's try this one more time. Coming out of moles, you're going to multiply by something. Going into moles, you're going to divide by something. Coming out of moles, you're going to multiply. Going into moles, you're going to divide. Out of moles, you're going to multiply. Into moles, you're going to divide. So that's a little trick that may or may not help you. The other thing that's going to help you always is put the S4 unit on top of the given unit in your conversion factor. That will get you with the things in the right place, hopefully. Okay. And yeah. So let's try some. You need your periodic table also. So if you don't know where that is, find it. So I'm going to type it on here, but I really think you should write it, okay? If you want to type it, that's great. You don't have to. Just make sure you upload a picture of your work. All right, so the first problem says, how many moles is 2.17 times 10 to the 23rd particles? So I'm going from particles to moles. The asked for is moles. The given is particles. And remember, those can be ions, atoms, molecules, formula units, just depends. Okay. So what do I have? You write down your given, 2.17 times 10 to the 23rd RPs. I need a conversion factor that has what's asked for on top, what's given on the bottom. And when you set it up like that, this unit cancels the bottom unit. You're left with the unit the answer is supposed to have in the numerator. The next thing you have to do is reach back in your brain and figure out what's the number of things in a mole. Now, it says bromine. It could say carbon dioxide. It could say water. It could say carbon tetrachloride. It could say whatever. And that's one of the things that they do a lot is they throw in this weird stuff you've never heard of. I've never seen bromine in person in real life either. So it doesn't really matter what it is. The representative particles in this case for bromine happen to be molecules because bromine's a halogen and it's diatomic. That's not important for this particular problem. They could have put anything there, okay, and it would all still come out to be the same. You're going to take that number and divide it by 6.02 times 10 to the 23rd. Okay, so everybody go ahead and do that, please. One other thing I wanted to mention, because I saw this on the moles of chalk. Some people are doing things like 5.17317. But maybe what's in your calculator display, but that's not this number to the 17th power. It's that number times 10 to the 17th power. Also, don't put E here. Some people were doing this kind of stuff. That E means times 10. Okay, so don't write just E. All right. Turn to your neighbor, see what they got. See if it's the same thing. Lily, what'd you get? What's up? Absolutely, please do. So I'm going to keep mine all on one line, so it's not set up pretty, but it's just easier to type. What'd you get, dear? Are you using a little mine or yours? Okay, good. What'd you get?
I can get it because I can't figure out how to do the exponents because it's not working. Oh, no, use DB. So 2.17. DB. Another 7. You don't have to. Oh, okay. I was missing it. And then 23. Divided by 6.2. There you go. Nice. Did yours work?
Oh yeah, I got it.
Okay. All right.
What'd you get, Lily?
0.36.
0.36, and we got to keep going because both of these numbers have 3 sig figs. Yeah, so here's the deal. So it's 0. Probably most of you have a couple other digits. It depends on how much floating decimals you might have set in your mode on your calculators. You can change those if you didn't know. So I need to, oh, and I also have to put my units in here. So this should have been representative particles. And, oh well, heavens. Trying to make it correct and then it does something stupid. There we go. Of representative particles. There we go. All right, so the calculator is going to spit this out. It's fine, except you should only have 3 digits. So the 5 makes the 6 into a 7. You could round off. It just, most people would round up. The 6 or the 7 makes the 4 into a 5, and most people will round that to a 1. Okay, and then the units, the last thing you need to have is moles. So 2.17 times 10 to the 23rd represented particles times 1 mole per 6.02 times 10 to the 23rd. That means to divide. Gives you the 0.361 or 360. I'm fine either way. Technically, that probably should go off, but it's fine. Here, I'm going to fix it because it's going to bother me. Because 465 is less than 500, so it should have probably been a 0. All right, questions on that? Who got that right? Yay, a few of you. Okay, let's try another one. This one's a little bit trickier, and that's because it's dealing with a molecule of SO3, and it's asking about atoms. So there's all sorts of layers in some of these problems of what they're seeing that you know. Okay, so what do you call, let's try that. What do you call SO3? Turn to your neighbor, see if you can figure it out. What do you call SO3? What is that? I picked on them today. Pick on somebody else. Okay, not a lot of talking, so I'll just pick on somebody. Jaden, what'd you get? What is SO3? What's its real name? Beautiful. Since they're both nonmetals, you need the tri, and it's oxygen, so it becomes oxide. Excellent. So in one molecule of sulfur trioxide, there are 3 atoms. Excuse me, I so lied. There are 4 total atoms. There's 3 atoms of oxygen, right? So this one gets a little bit complicated. So SO3 is the same as SOOO. That's 4 atoms per molecule. Everybody agree?
Mm-hmm.
Good. All right, so you have been given 1.14 moles, and you're asked to find atoms. So let's put down what we're given first, 1.14 moles. And the first thing you can do is figure out how many molecules. Okay, so there are 1 mole has how many molecules? 6, 1, oh, there, times 10, 23. Right, everybody knows that. Okay. And then to get to atoms, we have to use this one, 4 atoms per 1 molecule. So that's a little hidden irritation because you know they're going to have the answer of this times this, including this one. So moles is what you're given. It goes on the bottom of your first conversion. That would give you molecules, but it wants atoms. So we have to get molecules into atoms. Now, again, packing all these units seems like extra work. It will pay off. Go ahead and push those through your calculator for me. So all you're really doing is doing this number times this number times this number. What'd you get for that? Tony, are you there? Anthony, were you there? Let me know what you get, Tony. I'm asking for the answer for the problem on the front board. Thank you. Justin, what'd you get?
I don't know if I drew it, but I got 2.7451.
Beautiful. So 2.745120. And what's the exponent?
24.
So 10 to the 24th atoms. Now, again, those are too many sig fig. There's too many digits for the number of sig figs we're allowed. So 0 does nothing to the 2, does nothing to the 1. That's over. So I would probably round this one up. So 2.75 times 10 to the 24th would be the correct choice. And again, that's atoms. All right. Getting the hang of it a little bit? No, you do not have to put it on the document. You can just upload the picture at the end, okay? Or at the beginning. It doesn't matter to me. All right, PCl3. What the heck is PCl3? Hannah, do you know what PCl3 should be called? You're on here, right? Oh, she disappeared. Okay, I don't see Hannah. H-I-J, nope. Okay. How about, and she's not here today, how about CJ? Beautiful, nicely done. I can spell, except on Mondays. So again, this is trichloride because phosphorus and chlorine are both nonmetals. So we need the prefixes. If that was aluminum, with 3 chlorines, all you would say is aluminum chloride. Okay, no tries going on because aluminum's a metal. All right. Next question is, what's the molar mass of the phosphorus trichloride? So periodic tables, everybody's got one, right? You're going to put phosphorus as molar mass. There's 1 atom of phosphorus. And then chlorine's molar mass times 3. So when you look at the periodic table, everybody got one? Anybody need one?
People in your position.
Periodic table, periodic table. All right. So when you look at phosphorus, what do you see, John?
Phosphorus. 30.9.
Okay, we're going to go ahead to the hundreds place. Is it 9.7? Okay. And that is grams per mole of phosphorus atoms. And then chlorine, what do you see for chlorine? Cade. 35.45 grams per mole of chlorine atoms, but we don't just have 1 mole of, or 1 chlorine atom, we have 3. So 3 times 35.45, and you don't have to do these all separately. I'm going to do them separate just because you can put parentheses around things and do that. So 3 times 35.45 is 106.35, I believe. And then you're going to add these 2 numbers together. And altogether, you should get 137.32. And I'd like you to go to the hundredths place, the pennies place on molar masses, grams per mole. And this is phosphorus trichloride. Okay. Same thing for sugar. Go. I'll let you guys do it on your own. Why is it doing that? Who thinks they got it? Nobody?
For all of them?
Yep, you got them all together.
30.34.
You're close, but not quite. It's 3 something. No. I actually go up a little bit because I do carbon 12.01, hydrogen's 1.01, oxygen should be 16. Yeah, it's 9994. So I think it's 342.34. Yes. That is the molar mass of sucrose. So that's how I know that this beaker has a mole's worth of sugar molecules because I weighed out 342.34 or 342.34 grams of sugar, molar mass of sugar. All right, let's try ammonium nitrate. I think we have time still. So, what is ammonium nitrate? There you go. Talk to your neighbor, see if you can come up with the formula. Back in the day, way back in January, we started talking about ions. February. It's on the wall, too. Katie, what's ammonium? Uh-huh. Absolutely. And it has a +1 charge. And then how about nitrate? Nick the camel stuff. Dominique. Oh, I'm so sorry. Somebody help her out. Nitrate. Yep. Perfect. And it has a -1 charge. So ammonium nitrate is 1 ammonium ion and 1 nitrate ion, positive and negative, right? 0 charge. Okay. So that's the first thing. So that's like a problem within the problem. It's so irritating. You have to not just know how to do molar mass. You have to remember how to do formulas. Okay. So there's nitrogen in there. And this is also tricky because there's a nitrogen in ammonium and there's a nitrogen in nitrate. So it's really 2 nitrogens. Okay. And then there's 4 hydrogens. And then there are 3 oxygens. And you will get good at the lower multiples of 16 for oxygen because oxygen's in lots of stuff. So 16.00 oxygen. Hydrogen, I like using 1.01. It's not that important. You can just go with 1. You'll be close enough. You'll be able to figure it out. And then the nitrogen is 14.007. So I go 14.01 because we round to the pennies place. And then you just multiply them. So that's 28.02. And then this is going to be 4.04. And this is, of course, 48. And when you add those all up, I think it's 80.06. Double check me. Perfect. All right. So that is how you do molar mass. These are going to be problems inside of problems. You're going to have to know how to do molar mass to solve for the other stuff later. All right, your homework tonight, would you please do the first 5 questions on the next section? If you want to try the conversions on volume, you can. If you don't want to, it's fine, but do these first things. What are all atoms compared to? What's an AMU? How do we measure the weighted average mass for each element? What's STP? What's molar volume? Okay. And that should take care of it for Monday. Questions from anybody at home who's still there?
After the first 5, are we going to do the rest of the page tomorrow?
Yes. Yep. Bring your calculator.